Okay, so Unit 3, Lesson 3, Proving Lines Parallel. This lesson is very similar to Lesson 2. Okay, so we're going to use properties of parallel lines to determine angle relationships. These are all angle relationships we worked with in Unit 3, Lesson 2. We are just dealing with the converse. So the first postulate we're going to deal with is the converse to the corresponding angles postulate, which says if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So if I'm given that the corresponding angles are congruent, I can say the lines are parallel. So applying that to a context here, we're finding the value of x that makes these two lines parallel. So in order for m and n to be parallel, the measures of these two angles given need to be congruent because these angles are corresponding. So that means that 3x plus 5 must be equal to 65. So I solve that. 3x equals 60. X has to be 20. And that should make sense because 3 times 20 plus 5 is 65, making these two angles congruent. So that's pretty much all there is to it. Now, I'm going to have you guys move ahead to the guided practice, and I notice there is a bit of a typo. You can't see the minus sign there. I apologize for that. So it's 5x minus 7. So kind of follow example 1, pause the video, work through it, and then check your answers with me. Okay, so for this guided practice, all I have to do is say these angles must be equal in measure for A and B to be parallel. So I take 5x minus 7 equals 98. I solve that. I get 21. I can go back and check that in the expression to make sure that that's the proper value for x. So x is 21 for that guided practice. Moving ahead, these are just the converses for all the other properties we talked about. Alternate interior angles must be congruent for the lines to be parallel. Alternate exterior angles must be congruent in order for the lines to be parallel. And then finally, consecutive or same side interior angles, those must be supplementary. Remember, means the angles add to equal 180 degrees, the measures, okay? So the consecutive interior angles have to be supplementary in order for the lines to be parallel. So moving ahead, and this is an example of something that I have actually used to install stairs before. So I've used properties of these parallel lines to install stairs. So one way to build stairs is to attach triangular blocks to an angled support like in the diagram. The sides of the angled support are parallel. So the two diagonals there are parallel. If the support makes a 32-degree angle with the floor, what must measure of angle 1 be so the top of the step will be parallel with the floor? So one thing here is I can say, and I'm going to have to explain using our kind of our postulates. The measure, if you see down here, measure of angle 2, we can say the measure of angle 2 is 32 degrees. And the reason it's 32 degrees is because this 32-degree angle and angle 2 are corresponding angles. So I'm just going to say they're corresponding. And if you think about it, if you're a good, carpenter, if you're a good builder, the floor as a line will be parallel with the top step. So if we think of those as lines, those are parallel lines. So when we think about this, if we look at angle 1 and angle 2, we think of these as parallel lines, this runner right here would end up being the transversal. So the measure of angle 1 would have to be 32 degrees because it's congruent to angle 2, and the reason that it's congruent to angle 2 is because those angles are alternate interior angles. So it's being able to see those connections in a diagram. That's an important thing because we're applying that to a real life context. So if you want to build steps the right way, these angles all have to be congruent. Now moving to the guided practice. Being able to tell whether line A is parallel to line B, you have to be able to tell if they're parallel based on the given information and then explain why using the proper converse. So take a second, see if you can identify those properties, and then I will explain them in a second. So pause the video, try these on your own, and then check your answers with me. Okay, so to explain the guided practice, in number 3, yes, we can say the lines are parallel because the alternate exterior angles are congruent. So they are parallel by the converse. Drop the E off of there. The converse of alternate exterior angles. So yes, those are parallel. Number 4, yes, A and B are parallel because that satisfies the converse of the corresponding angles theorem. The corresponding angles are congruent, so those are parallel. In number 5, we can't necessarily say that the lines are parallel because these two angles represent alternate interior angles, and for the lines to be parallel, alternate interior angles must be congruent. So they don't necessarily always add to equal 180 degrees. They must be congruent though. So moving ahead to our last example. This talks about the transitive property of parallel lines. And basically what it says, if two lines are parallel to the same line, then they're parallel to each other. So if we look at this, if I say that P is parallel to Q and Q is parallel to R, that means that P is parallel to R. So if two lines are parallel to the same line, they're all parallel to each other. And that's represented with these streets in this last example. It says the map shows part of Denver, Colorado. And it says to use the markings on the map to see if the numbered streets are parallel to one another. And we're going to explain. So to explain this, I'm going to start with 20th Avenue. So I'm going to just label these by the name of the street. So I'm going to say 20th Avenue is parallel to 19th Avenue. And the reason I can say that is because of these angles, and that is because those are corresponding. And I'm just going to use a symbol for angles. So the corresponding angles converse. I can say that 20th Avenue is parallel to 19th Avenue. Then 19th Avenue, I'm going to use a different color for that. 19th Avenue, the angle there, and the angle on 18th Avenue, I can say that 19th Avenue is parallel to 18th Avenue, and that is because those angles, if we look at it, those are alternate exterior angles, and that's because of that converse of the alternate exterior angles. So those are alternate exterior angles. And then finally, 18th Avenue, this angle that's on 18th Avenue and this angle that's on 17th Avenue are congruent. So I can say 18th Ave is parallel to 17th Ave because those green angles there, those are alternate interior angles. So it's because of the alternate interior angles converse that I can say those angles, or those lines, those streets are parallel. So in the end, when I talk about this as all of these lines, or all of these streets being parallel, 20th is parallel to 19th, 19th is parallel to 18th. So 20th is parallel to 18th. 19th is parallel to 18th, 18th is parallel to 17th. So 17th is parallel to 19th, which is parallel to the 20th, so they are all parallel to each other. So at the end, we would say all streets are parallel by the transitive property. So that's why we studied those properties in the last unit. So the transitive property says if one line is parallel to the other, and the second line is parallel to a third line, they're all parallel to each other. So 20th is parallel to 19th, which is parallel to 18th, which is parallel to 17th. So now I think you're ready for the practice, so you can move on. Make sure that you are referencing your notes. Make sure you come back to the videos if you need something explained, or you get a hold of me and I will explain through things with you.